Hello, Leiden geometry students. Today, in this assignment, we're going to talk about parallel lines, transversals, and angle pairs. We're going to talk about four basic vocabulary words, at least at the beginning here. The words are parallel, perpendicular, intersecting, and skew. Out of those four words, you almost certainly already know what one of them is, or you think you do. You might know one or two of the other ones, but you almost certainly don't know the last. So we're going to have to take our time and talk about what each of these words represents. First, we're going to imagine this room is the room that you're in, and each wall represents a flat surface, including the floors and the ceiling. And a broomstick, these are just sticks in the room, each of these broomsticks represents a line. Here are two lines on the floor. They're touching right here. They are in the same plane, they're on the same surface. If they are touching, we call them intersecting. We use the word intersecting instead of touching in geometry just because touching sounds a little weird. So these are intersecting lines. That just means that they touch. Here are two other intersecting lines. Anytime you can find two that are touching each other, that's intersecting. Here are two other intersecting lines. And intersecting lines are any lines that touch, even if you can't see it. For example, these three pictures show intersecting lines. These first two lines touch or intersect right here. The second two intersect here. This last pair of lines are intersecting lines, even though you can't see where they touch each other. You know that they're going to touch each other somewhere off to the right side of your screen. Even if you can't see that they're going to touch, if you know they're going to touch, they are considered intersecting lines. Next word, perpendicular. Perpendicular lines are intersecting lines, but they're special intersecting lines. Perpendicular lines are lines that make right angles. These two lines are perpendicular. When we make right angles, we say the angle is a right angle, but the lines are perpendicular. They're almost interchangeable, but we're describing two different parts. Right angle describes the angle, perpendicular lines describes the line. If we have a right angle at the intersection of two lines, then we always have four right angles. All these angles turn out to be 90 degrees. We can represent the word perpendicular. It's a long word and sometimes hard to spell. We can shorten that up with this little symbol, this upside down capital T. In other words, if this is line M and this is line S, and I want to say that they are perpendicular, I can write M is perpendicular to S. This upside down capital T is our symbol for perpendicular. If you decide to use this instead of writing the word perpendicular, and you may, just make sure that it is clear what this thing is. It's not an L and it's not a plus sign. It's an upside down capital T that represents the word perpendicular. So back to our room, we're going to talk about our third word, which is parallel lines. Parallel lines are lines as you think of them, probably if you know this word. You think of them as lines that don't touch, but it's a little bit more than that. Parallel lines are any two lines that are in the same plane or on the same surface and don't touch each other. For example, here's two broomsticks on the floor, one on the left side, one on the right side. If the room, unless it's built poorly, if the room was to continue, these two sticks, and if they went on forever, should not touch each other. Most of us think of parallel lines as lines going the same direction, but there's an extra step there. We have to say that they're in the same plane or on the same surface. Even if two lines aren't touching each other, like these two aren't actually touching, but that's because they're not lines. The sticks that we're using to represent them are actually just segments. We know if we extended them, they would touch or intersect somewhere over here, so these are not parallel. That's why for parallel, we usually actually use the definition that two lines that are always the same distance apart. That way, we don't have to worry about whether or not they're intersecting, and it saves us the trouble when we talk about something called skew lines in just a moment. But parallel lines are always the same distance apart. When we have parallel lines, we draw them like this, and rather than writing out the sentence, these lines are parallel to each other, we add these little marks to the picture, these little arrow marks. We're going to use these little marks in geometry a lot, but this little arrow that we've added to each line, matching arrows, indicates that these two lines are parallel. Adding the marks to the picture is much shorter than writing out the sentence that these two lines are parallel to each other. In this picture, which two lines look like they're parallel? And if you look at the picture, we have line M, line N, line P, and line S. Which two look parallel? Well, you think it's lines M and P. Those are the two that look like they might be parallel to each other. The problem is we don't know that for sure unless we have some way to we're told or we can measure them somehow. But now if we add in these little arrows, now we know that they are definitely parallel to each other. Line M and line P are parallel to each other. We represent that with this little symbol right here. Line M is parallel to line P. The symbol for parallel is two slashes. It looks like a set of parallel lines. That's why we use that for the symbol for parallel. In this picture, if I ask you, are the lines parallel or intersecting, it's pretty easy to tell if they're touching each other. But if I ask you if A and B are parallel, your first instinct might be to say that they are. But we don't know that. They might be parallel, but we don't know that for sure unless we have some sort of measurement to tell or we're given these arrows. In this problem, we see the arrows and we know for sure that lines K and J are parallel to each other. Those two lines are parallel. How do we know? These arrows are telling us that they are parallel. We can show parallel lines a couple different ways. Here, these two lines are parallel because they have these little matching arrows. And then over here, these two lines are parallel. Notice to pair these two up with each other, I use a different set of arrows. I just add another one. So this line has two arrows. This line has two arrows. That means that they're parallel to each other. Here, I got a set of parallel lines where we have the angles numbered. We've seen that before a couple times now. We talk about 3D shapes. Parallel can be a little bit trickier. Here, if I have a box or a room or however, whatever you want to think about this, but a three-dimensional shape, we can identify parallel lines. These two lines are parallel. They can be parallel because they're on the same surface and they'll never touch each other. These are both on the front of the box. They could be on the side of the box like this instead and still be parallel. We could do it in other 3D shapes, but when we get to 3D, it's a little hard to tell if they're parallel, especially without the arrows. But one thing that people have a little bit of trouble with is something from their 8th grade art class where you see a picture like this, what's called the perspective drawing, where you learn to draw with a vanishing point and a horizon. And in this case, the parallel lines are misleading. If you look at the picture, you'd expect that the left side of the road and the right side of the road should never touch each other, otherwise the road would end. But the way the human eye sees it is eventually these lines get closer and closer together until they reach the vanishing point there. But we know that these lines actually are parallel, even though the picture doesn't show it. So in geometry, we do not use these perspective type drawings. Next, we're going to talk about skew lines. Here we have a picture of what are called skew lines. It's hard to tell that at this angle, but that's kind of the point. From this picture, it looks like these lines touch right here at point B, but this is a three-dimensional picture. In order for lines to be skew, you have to be looking at a three-dimensional picture. If I turn the picture a little bit like this, you can see that these lines never touch each other. They pass by each other without touching. They're passing by each other in different planes. That is what skew lines are. So skew lines are lines that don't touch but are still not parallel. In order to see skew lines, we have to be looking at something of a three-dimensional picture. Imagine this is the room you're in. This is you standing right there. A pair of skew lines are lines that wouldn't touch each other but are not going the same direction. For example, this line up here where the front wall touches the ceiling, that's an edge, and that's this line where they touch. And this edge down here where the floor touches the wall on the left. These two lines are not going to touch each other, even if you extend them forever and ever, at least in this 3D image. But we also know that they're not parallel because they're not going the same direction. So lines do not touch, but it's not because they're parallel. It's because they're in different planes or on different surfaces. That's what skew lines are. Parallel lines, on the other hand, would have to be on the same surface or in the same plane. So these are skew lines. Next, we're going to talk about a transversal. A transversal is just a line that crosses two or more lines. That's all a transversal is. This pink line here in the picture, that's a transversal. Why? Because it crosses two other lines. In each of these pictures, we want to identify the transversal. It's the line that touches both of the other lines, that intersects them both. For example, in the first picture here, we have lines A and B and C. Which one touches the other two? Well, it's line C. In the second picture, we have K, L, and M. Which one line touches the other two? It's line K. In the third picture, it's line H. In the fourth picture, which line is it? It's line S. Okay, when we have a transversal crossing two other lines, we create 8 angles. Now I have them numbered here just to make it easier to talk about the angles, but it doesn't matter which number is where. It's not like we always start up here in the top right for number 1. We can take these numbers and move them around. Doesn't matter. This is just shortcut naming. The numbers don't have to be in the same location. But in this case, what we want to focus on is the relationship between the different angles based on where they are in the picture. Okay, we are going to use 2 words to describe our angles usually. The first word is interior. The interior angles are the angles between two of the lines. All these angles here in the middle that are between the lines, these are called interior lines. You know the word interior, it means inside. So it should make sense that these angles on the inside, 3 and 4 and 5 and 6, these are interior angles. If those are the interior angles, then the exterior angles are the ones that aren't on the inside. Exterior means outside. So that would be angles 1 and 2 and 7 and 8. These are the exterior angles. I always think of this as a sandwich. And from the sandwich, if I look at the bread as the 2 lines and then the toothpick sticking through there as the transversal, the interior is all the stuff that makes up the inside of the sandwich. And the exterior is the stuff that's outside the sandwich. Inside, outside, interior, and exterior. So these are interior angles in between the lines, inside the sandwich, and the ones that aren't inside the sandwich are the exterior angles. You might think, well, why can't I just call them top and bottom or stuff in the middle? Well, because I can kind of take the same picture and turn it sideways, and then the top and the bottom doesn't make sense here. So we have to know it as the inside the lines or outside the lines, interior versus exterior. The next thing we're going to describe our angles with is the words same side versus alternate. And when we talk about this, we're talking about whether they're on the same side or different sides of the transversal. In this picture, these 4 angles, angles 1, 4, 6, and 8, they're all on the same side of the transversal. They're all kind of to the right side of the transversal down the middle here. So we would call any pair of these same side. But if we had 2 angles that are on different sides, like for example angles 3 and 6, we don't call these opposite sides or different sides. We call these alternate. Why? I don't know. But if they're on different sides of the transversal, we call them alternate angles. For quick practice, here's my transversal. It's the same transversal from the previous problem. I'm going to put 2 things on here. Roadrunner and Coyote. Are they on the same side or alternate sides? And these guys are on different sides, so we say they are alternate. How about now? Roadrunner and Coyote, same side or alternate? Now they're on the same side. How about now? Again, they're on the same side, they're just on the other side. And that's all it takes to decide if something is same side or alternate. So we're going to take that information and put it together. And instead of naming the angles with numbers, we're going to put in these little cartoon characters. And we're going to ask about these angles. First thing, though, we need to identify when we see a picture like this, where's our transversal? This line, the one that's glowing now, that is our transversal. So if I name 2 angles, in this case we're going to name 2 of the characters here. If I name 2 of the angles, the first thing we want to decide is whether they are on the same side or alternate from the transversal, and then whether they're interior or exterior. Let's start with these 2. So we talk about Superman and Daffy Duck. So the first question, are they on the same side of the transversal or alternate? They're on the same side, right. They're both above and to the right of the transversal. The second question, are they interior or exterior angles? Are they between the lines or outside the lines? These are exterior. They're not in the middle of the sandwich. They're on the outside of the sandwich. So they're same side and exterior. We call that same side exterior. It's a lot to write down. We usually shorten that up. Same side gets abbreviated SS, and exterior gets abbreviated EXT. So we just say SSEXT for same side exterior. Let's try another problem. Here we're going to look at Batman and Homer Simpson. First question you have to ask yourself, are they on the same side or alternate sides? And they're on alternate sides of the transversal. They're on different sides of our highlighted line here. So these are going to start with alternate. Then we decide if they're interior or exterior. Homer and Batman are on the inside of the sandwich, so they are interior. These are same side interior angles. Or, oh, I got that whole thing wrong. I'm sorry, I think I said that wrong. Batman and Homer are alternate interior angles. These are on alternate sides of the transversal, and they're on the inside of the sandwich, so they are alternate interior angles, which we would abbreviate as alt for alternate and int for interior. There's another type of angle pair besides same side and alternate, interior and exterior. They're called corresponding angles. Corresponding angles are actually kind of easy. It just means they're in the same spot at a different intersection. For example, angle 2 here is in the top left corner of this top intersection. Which angle is in the top left corner at this lower intersection? It's going to be angle 8. They're both in the top left. That's what corresponding means. Corresponding means in the same place at a different intersection. I think of it as streets. This is in Chicago. This is Ogden Avenue meeting. I think this is right under the Eisenhower Rabbi Stroger Hospital or the United Center where the Blackhawks and Bulls play. This corner is in the northwest corner of this intersection. This is the northwest corner of the other intersection. They're both northwest corners. That's what corresponding means. They're not interior or exterior. In fact, you have one of each. That's usually the giveaway that you're going to be looking at corresponding angles. Corresponding angles means in the same place at two different intersections. So if we looked at this picture, we already established angle 2 goes with angle 8. Those are corresponding angles. What is the corresponding angle with angle 1? Well, angle 1's in the top right corner, so its corresponding angle is angle 5. Angle 7 corresponds with angle 4, both in the bottom right, and angle 3 corresponds with angle 6, both in the bottom left. So, a couple practice problems. What's the relationship between Superman and Dora? First, decide are they same side or alternate, and then decide if they're interior or exterior. Superman and Dora are alternate exterior angles. How about, oh, we already did Homer and Batman, so let's try the Roadrunner over here on the left and Bugs Bunny down here. Roadrunner and Bugs Bunny. So the first thing you'd ask yourself, are they same side or alternate? And then are they interior or exterior? And this one's a little bit tricky because they are same side, but the Roadrunner is an exterior angle and Bugs Bunny is an interior angle. So when that happens, you need to check to see if they're corresponding. These two angles are in the same location. The Roadrunner's at the left side of his intersection and Bugs Bunny's at the left side of his intersection. These are corresponding angles. How about Superman and Daffy Duck? I think we already did that one. So let's try the Roadrunner and Dora the Explorer here. Take a look at the Roadrunner and Dora the Explorer and try to identify what their angle relationship is. Okay, first off, they're on the same side of the transversal, but they're on the exterior of the lines, so these are same side exterior angles. Okay, we can make the picture more complicated by simply adding more lines. We can make the picture look like this and add a few more characters. I know you get all excited about Elmo. Or more complicated by adding even more. Or even this picture. When the picture gets more complicated with extra lines, there's a simple way to simplify what you're looking at, to only look at the parts that we care about for two angles. For example, if we want to know what's the relationship between Homer Simpson and Elmo in this case, what you want to do is just focus on the lines that are making those two angles. Usually we do this with a highlighter or a crayon. For example, I go to the Homer Simpson angle up here, and I'm going to highlight Homer Simpson's angle. And the same thing down here with Elmo. I'm going to highlight that angle. Then I'm just going to extend these lines that I've highlighted. This one right here that's part of Homer, and this one, and then same thing down here with Elmo. And if I do that, our picture is going to look like this. And this is the only part of the picture we actually care about. All this stuff over here on the right, this is a line that's actually not part of this problem. And so all these angles we don't need to look at, nor this line. So all we really care about is this picture. If this is the case, now it should be easy to tell what's the relationship between Homer and Elmo. Decide, first question to ask yourself is, are they actually corresponding? If they're not corresponding, then decide if they're same side or alternate. Then decide if they're interior or exterior. Homer and Elmo are corresponding angles. They're both in the upper right corner of their intersections.